for the initial basic vectors are 1, 0, 0, 1 with the variables a1 and a2. What are the steps? As usual, convert these 3 as 1 by dividing the entire row by 3 and convert this 1 by 6 as 0 by using the elementary row operation. This is very important concept. The initial table for the phase 2 would be the exactly same as the solution stage with all the variables intact except for the absence of artificial variables. Hello dear students, welcome to this session of our Operation Research class. I am Mr. Niranjan, faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Now in my previous class we have discussed the problems based on solving a linear programming problem using simplex method as well as big M method. Now yet in this session today I am going to discuss a very important concept, that is solving a linear programming using two-phase method. So this is also a very important concept. So the problem itself indicates there are two phases. Let me explain the concept first. Now to solve a linear programming problem using two-phase method. So this is another technique to solve the linear programming problem which involves the artificial variables a1, a2, a3, etc. Now this is also another technique to solve the linear programming. So two-phase method is another technique to solve the linear programming problem using the artificial variables a1 and a2, a3, etc. an. Now as the name suggests, there are two phases. So the two phases consist of, in the first phase, the first step in the phase 1 is to construct an auxiliary LPP from the given original objective function in such a way that in the objective function all the slack variables, slack and surplus variables will have the coefficients as 0. So in the auxiliary linear programming problem, so we have to construct an objective function in such a way that the coefficient of slack variables as well as the surplus variables are 0. The coefficients of slack variables and surplus variables are 0 is the coefficient. Now, while the artificial variables have negative sign, so whereas the artificial variables will have negative as their coefficient. So a1 and a2 etc. an will have the coefficients as -1, minus a1, minus a2 etc. minus an. So the slack and surplus variables will have the coefficients as 0, whereas the artificial variables will have the coefficients as -1. So therefore the objective function can be written as max z is equal to 0x1 plus 0x2 plus 0s1 plus 0s2 etc. minus a1 minus a2, such that the constraints as equation can be written as z bar, that is z star or z bar, z star. So when the LPP in the format shown is solved using the standard simplex method. So this can be solved using the standard simplex method. Now while solving, there are two cases or arises. So what are the two cases? In the first case, case number 1, maximum of z star is less than 0. If maximum of z star is less than 0, at least one of the artificial variable appears in the basic variables list at the solution stage. Suppose if maximum of z star is less than 0 and at the solution stage, if one artificial variable a1, a2, a3, any one artificial variable is appeared, then in such a case the LPP does not have any solution and it is terminated as the phase 1 itself. This is very important concept. So while solving the problem, if any one artificial variable appears in the solution stage, then we have to conclude that there is no solution for the given problem, the feasible solution, and LPP does not have feasible solution and we can terminate at the phase 1. Now case number 2. What is case 2? In second case, if maximum of z star, if max z star is equal to 0 and no artificial variables appear among the basic variable at the solution stage, in such a case the LPP has a feasible solution and goes to the next phase to find the optimality. Then we will go for the next phase to find the optimality. So here in case number 2, if, what is the case 2? if no artificial maximum of z star is equal to 0 and no artificial variables are appears at the solution stage, then the LPP has a feasible solution and goes to the next phase to find the optimality. Okay, now again in phase 2 there are two possibilities. In phase 2, to begin with a new objective function is written by taking the original problem in the maximization form. In the objective function, all the slack and surplus variable including artificial variables assign 0 coefficient, while the decision variables retains the original coefficient. So, in the modified form of the objective function, original problem in the maximization form, the original problem is always in maximization problem, and in the objective function, all the slack variables, surplus variables including artificial variables are all assigned to 0. So, slack variable, surplus variable, artificial variables are all assigned to 0 and the coefficients, while the decision variables retain their original coefficients. So, the decision variables will retain their original coefficients. And again, to continue the phase 2, a new simplex table is constructed where the artificial variables are ignored altogether. So, in the simplex table, in the phase 2, in the second step, in simplex table, while constructing, the artificial variables are ignored altogether. The initial table for phase 2 would be exactly as the solution stage. This is very important concept. The initial table for the phase 2 would be the exactly same as the solution stage with all the variables intact except for the absence of artificial variables and the presence of new coefficient of basic variables and the coefficients of the variable elements. So, now the last one is, now the simplex method is applied to arrive the solution stage and get an optimal solution. So, this can be solved using the same procedure as in the simplex table. So, using the simplex table procedure, we can get the optimality of the given linear programming problem. This step-by-step procedure to solve a linear programming problem is called a solution of LPP using two-phase method. Now, let us take a small example. Now, let me solve a problem. Solve the following LPP using two-phase method. Max z is equal to minus 4x1, minus 3x2, minus 9x3 subjected to the constraints 2x1 plus 4x2 plus 6x3 is greater than or equal to 15, 6x1 plus x2 plus 6x3 is greater than or equal to 12 and x1 comma x2 x3 are all greater than or equal to 0, non-negative restriction. So, this is a 8 marks question. Usually, you will get this type of problem for a 8 marks. So, what is the objective function? Max z is equal to minus, so this is of maximization type. Further, what are the constraints given? So, greater than or equal to 15 and greater than or equal to 12. Let us modify, let us rewrite the given objective function. So, what is given? Maximum of z is equal to, max z is equal to minus 4x1, minus 3x2, minus 9x3. Now, convert all the coefficients as zeros except for the artificial variables. So, all the coefficients are 0 except the artificial variables. Constraint into the standard form. So, the given equation can be put in the form max z is equal to 0x1 minus 0x2 then minus 0x3 again plus 0s1 plus 0s2 minus a1 minus a2. Okay, and for this, just since it is greater than or equal to, the constraints can be written as 2x1 plus 4x2 plus 6x3 minus s1 is equal to 15. Let us convert this. 2x1 plus 4x2 plus 6x3 minus s1 plus a1 is equal to 15 and second equation is 6x1 plus x2 plus 6x3 minus s2 minus a2 is equal to 12. Now, the modified objective function and the constraints can be written as the objective function written with 0 coefficient for all the variables. So, max z is equal to 0x1 minus 0x2 plus 0s1 plus 0s2 and except for the artificial variable with coefficients as minus 1, minus of 1 a1 minus 1 a2. So, the objective function can be written with 0 coefficient for all the variables except for the artificial variables as -1. So therefore max z is equal to 0x1 minus 0x2 plus 0s1 plus 0s2 minus a1 minus a2. Okay. So therefore max z can be written as maximum of z is equal to 0x1 minus 0x2 minus 0x3 plus 0s1 plus 0s2 minus 1 into a1 minus 1 into a2. Similarly, the second equation can be written as 2x1 plus 4x2 plus 6x2. So the constraint subjected to the constraints 2x1 plus 4x2, 2x1 plus 4x2 plus 6x3 minus s1 plus a1 is equal to 15, and second equation 6x1 plus x2 plus 6x3 minus s2 plus a2 is equal to 12. Let me write the coefficients for this. So what are the coefficients? x0, x1, x2, x3, s1, s2, a1 and a2. Now for the constraints, what is the values of x0? The values are x0 are 15 and 12. For the first equation, the coefficient of x1 is 2, this is 4, 6, and s1 is -1, s2 0, a1 is 1, a2 is 0. Similarly, for the second equation, x1 is 6, x2 is 1, x3 is 6, s1 coefficient is 0, s2 is -1, a1 is 0, a2 is equal to 1. So if you observe carefully here, this form an identity matrix of order 2 rows and 2 columns. So 1 0 0 1 is an identity vector. So therefore the initial basic vectors are 1 0 0 1 with the variables a1 and a2. Okay. Now what are the coefficients of a1 and a2? Here the coefficients of a1 and a2 are -1 and -1. So using this we are going to construct the initial simplex table. Now let us come to the initial simplex table. Now in the initial simplex table I am going to take a1 and a2 as the coefficients of basic variables. So the initial vectors are a1 and a2. The coefficients of basic variables are -1 and -1. And the values of x0, x1, I will start from here. So 15, 12, this is 15, 12, and the values, what are the values? We have 2, 4, 6, 2, 4, 6, again 2, 4, 6, -1, 0, -1, 0, again 1, 0, 1, 0. Again similarly, if I come to the second row, so 6, 1, 6, 6, 1, 6, again 0, -1, 0, -1, again 0, 1. So these are the values. So just substitute the values of x0, x1, x2, x3, s1, s2, a1, a2 from the previous objective function and the constraints. Now, so here all the values of the objective functions except a1 and a2 are -1, -2, remaining coefficients are 0. Now let us find out the value of zj as usual procedure. So the remaining procedure are same as that of the previous problems like initial simplex table. Now let us find out the value of zj. Now to find out zj, zj is equal to multiply these two. -1 into 15, -1 into 15 plus -1 into 12, -1 into 12. So -15 minus 12, this is equal to -27. The first value is -27. Again -1 into 2 is -2, -6, that's equal to -8. There this is -8. -1 into 4 is -4, -1 is -5. Again -1 into 6 is -6, -1 into 6 is -6, -6 is -12. Minus into minus plus 1 plus -1 into 0 is 0, 1 plus 0 is 1. Again -1 into 0 is 0, minus into minus plus 1, this is equal to 1. Again -1 into 1 is -1 plus 0 is -1. Again -1 into 0 is 0, minus into plus it is -1. So that's equal to -1. So these are the values of zj. Okay. Now after finding the values of zj, find out the value of delta j. What is delta j? As you know, delta j is equal to zj minus cj. Now what is zj? this minus 8 minus 0 is equal to minus 8. This is minus 8. Again, all are zeros, so you will get the same values. Minus 5 minus 0 is again minus 5. Minus 12 minus 0 is minus 12. 1 minus 0 is 1. Again here, so minus 1 minus of minus 1, that's equal to minus 1 plus 1 is equal to 0. You will get this as 0. Again, if you come to this minus 1 minus of minus 1, minus 1 plus 1, this is again 0. So here these values are 0. So A1 and A2 are 0, remaining the values you are going to find. Now what is the procedure? Just identify the least negative in this delta J. So delta J least negative, identify the least negative. So here the least negative value is minus 12. Minus 12 is the least negative. So therefore this is the incoming variable. So incoming variable is, this is x3 is the incoming variable. So incoming variable. Now find out the ratio. What is the value for ratio? So the ratio is equal to, ratio is nothing but x0 divided by x3, x0 divided by x3. So here the incoming variables are x3, x0 divided by x3 will give the ratio. So what is x0? 15 divided by 6. 15 divided by 6. So 15 divided by 6 means 6 2s are 12, 3, 30 by 6, that is 2.5. 15 divided by 6, that is 2.5. Next value, 12 divided by 6. 12 divided by 6 is equal to 12. So, and the remaining minus 27 by minus 1, that is not required. So, here the ratios are 2.5. Now, identify the least positive value in the ratio column. So, what is the least? Identify the least value. Least positive value is plus 2. So, therefore, this is the outgoing variable. This is the outgoing variable. So, the outgoing variable are this. This is the outgoing variable. Now, identify the intersection of the row and column. Identify the intersection of incoming variables and outgoing variables. So, here 6 is the key element. So, the key element is equal to 6. Okay. This is how we are going to construct the initial simplex table, right? So, this is the first table, okay. Now, here in the next table, we will go for the next table. In the next table, initial simplex table, after this first iteration, in the first iteration, what are the steps we are going to perform? Here, first convert this key element as 1. So, divide each and every element by 6, this key element. So, R2 dash is equal to R2 divided by 6. Now, convert this 6 as 0 using the elementary row operation. Now, and further here, what are the outgoing variables? Here, outgoing variables are A2. A2 are the outgoing variables. This A2 is replaced by the incoming variable x3. So, here this A2 is replaced by x3. So, that is the steps we are going to perform in the next iteration table. Now, let us come to the iteration number 1. So, in the initial vector A1 and A2 is replaced by x3, the coefficient of A1 is minus 1 as it is and x3 coefficient is 0. And now convert this, R2 dash is equal to R2 divided by 6. Now, R2 dash is equal to R2 divided by 6. What are the elements of R2? We have 12, 6, 12, comma 6, 12, 6, 1, 6, 1, comma 6, 0, minus 1, 0, minus 1, again 0, minus 1, 0, 1. Okay. Now, divide each and every element by 6. If we divide by 6, what you will get? 2, 1, 1 by 6, 1, 0, minus 1 by 6, 0 and plus 1 by 6. Okay. These are the values. Now, since, see the important concept here. Since A2 is the outgoing variable, we can remove A2 from the table. So, here we can take A2 out. So, A2 is taken out. What are the elements left is x0, x1, x2, x3, s1, s2 and my a1. Now just write down the values here. So for r2 dash, what are the values we are getting? 1, 1 by 6, 1, 0, minus 1 by 6, again a2 is gone, a2 coefficient is 1 by 6 is gone, a1, so 0 we have. Okay, these are the values for r2 dash. Okay, now let us find out next, convert this element as 0. To convert this element as 0, we are going to perform the row operation. So now r1 dash can be written as, what are the elements we have here? 6, and here we have 1. So therefore r1 dash can be written as r1 minus 6 r2. What is r1? So the elements of r1 are, these are the elements of r1. So that is 15, 2, 4, 15, 2, 4, 6, minus 1, 0, 6, minus 1, 0, again 1. Okay, r2, what are the elements of r2? These are the elements of r2. Just multiply r2 with 6. If you multiply these elements with 6, you will get 6 2s are 12, 2 1s, 6 1s are 6 it is. So multiply all these elements with the 6, because r2 dash is 2 1. See here, what is r2 dash? We have r2 dash is equal to 2 1 1 by 6. Multiply these elements with 6. So if you multiply these elements with 6, 6 2s are 12, again 6 1s are 6, 6 6 gets cancelled 1, again 1 into 6 is 6, again 6 into 0 is 0, again 6 6 gets cancelled, minus 1, again 6 into 0 is 0. Okay, these are the values. Now subtract this. If you subtract, 15 minus 12 is 3, 2 minus 6 is minus 4, 4 minus 1 is 3, 6 minus 6 is 0, minus 1, 0, minus into minus plus 1 and plus 1. These are the values for r1 dash. So I'll substitute these values here. What are the values of r1 dash? r1 dash, these are the values. These are the values of r1 dash. 3 minus 4, 3, 3 minus 4, 3, again 0 minus 1, 0 minus 1, plus 1 and plus 1. So these are the values of r1 dash and the r2 dash. Now as usual, find out the value of zj. Zj is equal to multiply and find out delta j minus cj, that is delta j is equal to zj minus cj. Now find out zj. Zj is equal to minus 1 into 3 is minus 3, plus 0 into 2 is equal to 0, that's equal to minus 3. So this is minus 3. Again minus 1 into 4 is minus 4, plus 0, minus into minus plus 4, plus 0 is 4. Again 1 into minus 3 is minus 3 and 0 is minus 3 it is. Again 0 into 1 is 0 and 0 into 1 is 0, 0. Minus into minus plus, 1 ones are 1 plus 0 is 1. Again minus 1 into plus 1 is minus 1. Minus 1 into plus 1, it is minus 1, plus 0, that's equal to minus 1. Again 1 into minus 1 is minus 1, plus 0 is minus 1. Now find out the value of delta j. Now delta j is equal to zj minus cj. What are the values here? 4 minus 0. 4 minus 0 is equal to 4 you will get. Minus 3 minus 0 is minus 3. 0 minus 0 is 0. 1 minus 0 is 1. Minus 1 minus 0 is minus 1. And this value minus 1 minus of minus 1. Minus 1 plus 1 is equal to 0 you will get. Now since here you can see here this is the least negative value, minus 3 is the least negative value, so therefore this is the incoming variable again. So this is the least negative, the incoming variable is minus 3. So this is the incoming, so the incoming row, this is the incoming column. Now find out the ratios. So the ratios are here, the ratios are x0 divided by, what are the incoming variables? x2, x0 by x2. What is x0? x0 is 3 divided by 3, 3 by 3 is equal to 1. Again, x naught is 2 divided by 1 by 6. 2 divided by 1 by 6, that is 2 into 6 by 1, that is equal to 12. And this. Now identify the least positive value. Here the least positive value is plus 1. So therefore these are the outgoing variables. Outgoing variables. So outgoing variables are, so these outgoing call. Now identify the key element. What is the key element? So the intersection of incoming variable and outgoing variable, this 3 is the key element. Okay. Now here also, since there is least negative value, the optimality is not reached, hence we have to go for the next iteration, in the iteration number 2. So in the next iteration, what are the steps? As usual, convert this 3 as 1 by dividing the entire row by 3, and convert this 1 by 6 as 0 by using the elementary row operation. Okay. Now let us come to the iteration number 2. Now in iteration number 2, so here the variables A1 is outgoing variable, A1 is outgoing variable, whereas A1 is replaced by x2. So here we are going to get it as x2, x3, the coefficient of x2 and x3, and the outgoing variable is A1. Here in the next iteration, iteration number 2, x2 coefficient is 0, x3 coefficient is also 0, and the A1, A2 columns are deleted. Okay. Now let us come to the values. Now first find out R1 dash. R1 dash is equal to R1 divided by 3. Now R1 dash is equal to R1 divided by 3. What are the elements of R1 we have? So we have 3 minus 4, 3 minus 4, 3, 3 minus 4, 3, 0 minus 1, 1, 0 minus 1 and 1. Now divide each and every element by 3. So if you divide by 3, what you will get? 3 by 3 is 1, minus 4 by 3, 3 by 3 is 1, 0, minus 1 by 3 and plus 1 by 3. These are the values of R1 dash. So R1 dash, I will substitute here. 1 minus 4 by 3, 1 minus 4 by 3, then 1, 0, 1, 0, minus 1 by 3 plus 1 by 3, minus 1 by 3 plus 1 by 3. Now let us come to the second row, R2 dash. Here this element is converted as 0. For that, what is the operation we are going to use? For that we are going to use the row operation, as R2 dash is equal to R2 minus 1 over 6 times R1. R2 dash is equal to R2 minus 1 by 6 times R1. That's it. Okay. Now write down the elements of R2. What are the elements of R2? 2, 1, 2, 1, 1 by 6. 2, 1, 1 by 6, 1, 0, minus 1 by 6, 1, 0, minus 1 by 6. Okay. Let me check. 2, 1, 1 by 6, 2, 1, 1 by 6, 1, 0, minus 1 by 6. Next. Now multiply this with 1 by 6. R1, what is R1 dash? R1 dash, this is R1 dash, this is R1 dash. Multiply this with 1 by 6. If you multiply by 1 by 6, so 1 into 1 by 6 is 1 by 6. Again minus 1 by 6 into minus 4 by 3. So what happens? This is 2 2s are 2 3s are gets cancelled. Minus 2 by 9. This is minus 2 by 9. Again, so yes, 1 by 6 into 1 is 1 by 6. Again 1 by 6 into 0 is 0. Again 1 by 6 into minus 1 by 3 is minus 16, 1 by 16, 1 by 6 3s are 18, and the last one is 1 by 6 into 1 by 3 is 1 by 18 again. This is also 1 by 18. Subtract this, that's it. If you subtract, you will get the answer. What is the answer we are going to get? So 2 minus 1 by 6, 1 minus into minus plus 2 by 9, this is 0, 1 minus 0, 0 minus of minus is plus 1 by 18, minus 1 by 6 minus 1 by 18. So this is 6 is LCM, 6 2s are 12 minus 1 is 11 by 6, 2 is 9 is LCM, 9 1s are 9 plus 2 is 11, this is 0, this is 1, this is 1 by 18, and here it is 6 18 is the LCM, 6 3 is a minus 3 minus 1. So, what are the answer we are going to get? 11 by 6, 11 by 9, 0, 1, 1 by 18, comma, minus 4 by 18. These are the values. Now, let me substitute these values for R2 dash. R2 dash is equal to 11 by 6. So, here it is 11 by 6, 11 by 9, then 0, 1, 0, 1, then 1 by 18 and this one. So, we can also write this as 2 2s are 2 9s are minus 2 by 9, minus 2 by 9. So, these are the values for R1 and R2 dash. Now, as usual, find out the value of Zj. Now, find out the value of Zj. So, since these two are 0, if you multiply and add, you will get 0. 0 into 1 is 0 plus 0, this is equal to 0. 0 into 4 by 3 is 0 plus 0 into 11 by 9 is 0. 1 into 0 is 0 plus 0 is 0. Again, this is also 0, 0 and 0. What is delta J? Zj minus Cj. If you subtract 0, you will get 0, 0, 0, 0 and 0. So, that means all the values of delta J is equal to 0. That is Zj minus Cj is equal to 0. Right. So, here all the values are greater than or equal to 0. All the values are 0, no negative values. Hence, the optimality is reached. Now, we can proceed with the phase 2. Okay. So, from this table, the solution stage is reached. Then we will proceed with the phase 2. We will go for phase 2. Okay. Now, in the phase 2, this is very important. Come to the phase 2. In phase 2, the initial table is constructed with. Now, how to construct the initial simplex table? With basic variables as x2 and x3. The basic variables are x2 and x3, same as that of this iteration number 2. And whereas, let me explain. In phase 2, the initial table is constructed with the basic variables x2 and x3 as in the iteration number 2. The basic variables are same x2 and x3 and the coefficients are also 0 and 0. So, the basic variables as x2 and x3 was present in the solutions stage of phase 1. Ignoring the artificial variables a1 and a2. So, we are going to ignore the artificial variables a1 and a2 is already ignored. Then, assuming 0 coefficients for s1, s2 and s3 and taking the original coefficients of x1, x2, x3 as given in the original problem, that is in the maximization problem, from both coefficient of basic variables and the variables. Now, the standard form of the problem for the second phase will be like this. Max z is equal to minus 4x1 minus 3x2 minus 9x3 plus 0s1 plus 0s2 subjected to the constraints 2x1 plus 4x2 plus 6x3 minus s1 is equal to 15, 6x2 plus x2, 6x1 plus x2 plus 6x3 minus s2 is equal to 12, where x1, x2, s1, s2 are all greater than or equal to 0. Now, using this, we are going to construct the next table from iteration number 2. Write down the coefficients of x2 and x3. Here the coefficients of x2 and x3 are minus 3 and minus 9. Minus 3 and minus 9 are the coefficients. And the coefficients of the objective functions are here minus 4, minus 3, 9, 0 and 0. Minus 4, minus 3, minus 9, 0 and 0. The values for the table are from this table. So, these values are considered, that is from iteration number 2. So, in the iteration number 2, we have these R1 and R2. The values of R1 are 1, minus 4, 4 by 3, 1, 0, minus 1 by 3. And for R2, it is 11 by 6, 11 by 9, 0, 1, 1 by 18, minus 2 by 9. So, I am going to write all these values here. So, this is 1 here, minus 4 by 3, 1, 0, minus 4 by 3, 1, 0, again minus 1 by 3, plus 1 by 3. Okay, this is for R1. Now, let us come to R2. These values 11 by 6, 11 by 9, 0, 11 by 6, 11 by 9, 0, 1 by 18 minus 2 by 9. 1 by 18 minus 2 by 9. These are the values. So these are from iteration number 2. The values are from table 2. Okay. Let me solve the values for Zj. Zj is equal to, multiply these two. Minus 1 into 3 is minus 3, minus 9 into 11 by 6. Now this can be written as minus 3 into, divide by 3. 3 3s are, 3 2s are, minus 33 divided by 2. Take LCM, 2 is LCM, minus 6 minus 33 is minus 39 divided by 2. So this is minus 39 divided by 2. Okay. Now next, come to this, minus 3 into minus 4 by 3, minus 9 into minus 11 by 9 into 11 by 9. So 3 3 cancel, 9 9 cancel, minus into minus it is plus 4 minus 11, this is equal to minus 15. So this is equal to minus 4, yes, minus into minus plus 4, 4 minus 11, 4 minus 11 is equal to minus 7, this is equal to minus 7. Now let us come to the next value. Minus 1 into 3 is minus 3, minus 1 into 3 is minus 3, plus 0, that's equal to minus 3, this is minus 3. Again minus 1 into 0 is 0, minus 1 into 9 is minus 9. Minus 3 into 1 by 3, again minus into minus plus 9 into 2 by 9. So 9 9 gets cancelled, 3 3 gets cancelled, minus 1 plus 2 ones are 2, this is equal to plus 1. Here this is plus 1. Now find out delta j is equal to Zj minus Cj. Delta j is equal to, as usual, Zj minus Cj. So this is same, minus 7, minus of minus plus 4, this is equal to minus 3. You will get minus 3 here. This is minus 3, minus 3, minus 3, minus of minus it is plus 3, this is equal to 0. Again minus 9, minus into minus plus 0. Again 1 by 2 minus 0 is 1 by 2, 1 minus 0 is 1. See here, if it is all are positive, then the optimality is reached. Since here it is negative, minus 3, the least negative is minus 3. Again we have to go for a one more iteration. So therefore the least negative is this minus 3, therefore this is the incoming variable. So the incoming variables are, these are the incoming variables. Next one. Now find out the ratio. Now the ratio is equal to x naught divided by x1. X naught is 1 divided by minus 4 by 3 is equal to minus 3 by 4. Minus 3 by 4. So if you divide, you will get minus 0.73. Minus 0.73. Next, x naught 11 by 6 divided by 11 by 9. So this goes to the numerator, 9 by 11, 11 gets cancelled. So this is equal to 3 3s are, 3 2s are, 3 by 2, this is equal to 1.5. Now identify the least positive. Here only one positive, this is 1.5 is the least positive. Therefore these are the outgoing variables. So this is the outgoing variable. This is the outgoing variable. Now what is the key value here? 11 by 9 is the intersection of the incoming and outgoing variables. That is 11 by 9. So the key value is equal to 11 by 9. Now, so hence we have to go for a next iteration. In the next iteration number 3, convert this 11 by 9 as 1, divide this row by 11 by 9 and convert minus 4 by 3 as 0 using the elementary row operation, and find out whether delta j will satisfy the given condition or not. If it satisfies that given condition, then we can say optimality is reached. Otherwise, we have to go for one more iteration. Now, let us come to the next iteration. Now, in the next table, what are the elements here? So, here this x1 is the incoming variable and x3 is the outgoing variable. So, this x3 is replaced by x1. That's all. Now, let us come, and R2 dash is equal to R2 divided by 11 by 9. Now, let us come to the second. R2 dash is equal to R2 divided by 11 by 9. X3 is replaced by X1. X3 is replaced by X1. The coefficients are minus 4 and minus 3. Now, R2 dash. What is R2? R2 elements are 11 by 6, 11 by 9, 11 by 6, 11 by 9, comma 0, 1, comma 1 by 18, comma minus 2 by 9. Now, divide each and every element by 11 by 9. So, if we divide by 11 by 9, 11 by 9, 11 by 9, 11 by 9, 11 by 9. This is equal to 11 by 6 into 9 by 11. This 2 gets cancelled. 1. This is 0. This is 9 by 11. This is 1 by 18 into 9 by 11. This is minus 2 by 9 into 9 by 11. Simplify this. So, here 11 gets cancelled. 3 3s are 3 2s are 3 by 2 is the first element. 1 0 9 by 11, and here 9 2s are 18. 1 by 22. Again 9 gets cancelled. Minus 2 by 11. These are the values we will get. Okay, I will substitute this for R2 dash. R2 dash is equal to 3 by 2, 3 by 2, 1 0 1 0, 9 by 11, 1 by 12, 9 by 11, 1 divided by 22, and minus 2 by 11, minus 2 by 11. So, these are the values. Now, convert this minus 4 by 3 as a 0. See here. So, the R2 dash for this is R2 dash. R2 dash is equal to, these are the elements, 3 by 2, 1, 0, 9 by 11, 1 by 22, minus 2 by 11. So, I will substitute here. To find R1 dash, now for R1 dash, let us make use of here, since the element we have is minus 4 by 3. So, therefore, using minus 4 by 3, we can write R1 dash is equal to R1 plus 4 by 3 R2. That's it. Using this elementary row operation, R1 dash is equal to R1 plus 4 by 3 R2. R1 plus multiply R2 with 4 by 3 and add. So, what are the elements we are going to get? We are going to get it as 3, 0, 1, 12 by 11, then minus 3 by 11 and 1 by 11. So, these are the values we are going to get. Simplify this using this property. Row operation, R1 plus 4 by 3 R2 gives rise to 3, 0, 1, 12 by 11, minus 3 by 11 and 1 by 11. Just substitute the value of R1 and multiply R2 with 4 by 3 and add, you will get this answer. So, I will substitute these values here. 3, 0, 1, 3, 0, 1, again 12 by 11, 12 by 11, minus 3 by 11 and 1 by 11. So, these are the values. Okay. See, so this is R2 dash and R1 dash, R1 and R2. Now, as usual, find out the values of Zj. Now, Zj is equal to, here Zj can be written as, Zj is equal to 3 3s are 9, minus 9, minus into plus it is minus. So, 4 into 3 by 2, 2 2s are gets cancelled, minus 9 minus 2 3s are 6, this is equal to minus 15. So, the answer here it is minus 15. Now, similarly, 3 into 0 is 0, minus 1 into 4 is minus 4, minus 1 into 3 is minus 3, plus 4 into 0 is 0. So, minus 3 plus 0 is minus 3. Again, minus 3 into 12 by 11, minus 3 into 12 by 11, minus 4 into 9 by 11. Take LCM, 11 is the LCM, minus 36, minus 36. So, this is equal to minus 72 by 11. So you will get minus 72 by 11. Next, so minus 3 into minus 3 by 11 plus minus 4 into 1 by 22. So this is 2 1s are 2 2s are 2 11s are. So take LCM, 11 is LCM, minus into minus plus 9 minus 2, this is also equal to 9 minus 2 is 7 by 11. So this is equal to 7 by 11, and the last one is minus 1 into 3 is minus 3 by 11, minus 3 by 11, minus into minus plus 4 2s are 8 by 11. Take LCM, 11 is LCM, 8 minus 3, 8 minus 3 is equal to 5, 5 by 11. So this is 5 by 11. These are the values we are going to get. Now just find out the value of delta J, Zj minus Cj. So this is here minus 4, minus into minus plus 4, this is equal to 0, minus 3, minus into minus plus 3, this is also equal to 0. If you simplify this, minus 72 by 11, minus into minus plus 9, take LCM, 11 is the LCM, minus 72 plus 9 11s are 99. So 11 9s are 99, 99 minus 72, this is 7 and 2, 27 by 11. So this is 27 divided by 11. Now similarly, 7 by 11 minus 0 is 7 by 11, 5 by 11 minus 0 is 5 by 11. Now observe carefully, all the values of delta J are greater than or equal to 0. See, this is delta J is greater than or equal to 0. So that is the value of all the values of delta J are greater than or equal to positive or greater than or equal to 0. Therefore, the optimality is reached. Optimality is reached. And what are the values? So the optimal solution is minus 15, and the values of x1 is 3 by 2 and x2 is 3. So therefore the values of x1, therefore x1, x2, x3 is equal to, what is x1? x1 is 3 by 2 and x2 is 3 and x3 we don't have, and the maximum value is Z maximum is equal to minus 15. Okay. So hence the optimality is reached. Therefore Z star maximum is equal to minus 15 at x1 is equal to 3 by 2, x2 is equal to 3 and x3 is equal to 0. This is the solution for the given LPP. The solution for this problem is minus 15 at x1 is equal to 3 by 2, x2 is equal to 3 and x3 is equal to 0. So this type of finding the solution is called solving an LPP using two-phase method. That's it. Okay. Here the number of iterations are more. That's all. So that's regarding today's session. Let us meet with a different problem in the next class. Thank you. Thank you very much.